Okay, so yeah, we just have to find a...
Yeah, we just gotta find an equation and then just solve for the resolutions and then just compare them basically.
Perfect.
Yeah, I'm trying to remember what the...
So you're looking for
Equation is-
something with wavelength, so lambda rate, and then...
Yeah, and then the diameter. I think we're just using this.
Theta.
Yeah, because this is
Okay.
resolution of telescopes.
Perfect.
So we have wavelength. This is just, yeah, and then D is just diameter of the, like,
That makes sense.
yeah, of the objective lens.
In meters, you think? Imagine.
Yeah. Well, you could use, yeah, I would convert it to meters. I would convert all these. So I'd convert that to meters, that to meters, that to meters, and that to meters.
Okay.
So,
Okay, so even for the lambda, for the wavelength?
yeah,
put it on-
right.
Okay.
Because you want those
As long as you
units
have...
to cancel. Yeah.
Oh, okay.
Right. As long as you have all the same units, but might as well just make it all meters.
Perfect, yeah, I agree.
Yeah, so we have, oh yeah, there you go.
1.2 type, 1.22 lambda over just the diameter.
Yep, yeah, exactly. Yeah, so we have, okay, so for the first one, let's just do the backyard telescope first. We have 4 inches.
Mm-hmm.
So it's like 1 centimeter is, I don't know.
It's like 2.54.
Yeah, it's centimeters to 1 inch.
Yeah.
Yeah.
So I can probably figure it all out, you know. It's just pretty basic math. But what?
Yeah, that is, I guess, yeah, you could figure.
No, I mean, so I just put, so 1.22 times the wavelength for each
Yep.
one, and then the diameter for each.
Mhm.
And so I'll get a number and a numerical value for each.
Mm-hmm.
And that's considered the resolution?
Yep,
Okay.
yeah, that's the angular resolution.
Do you know the units for that, per chance?
I don't. Let me see. I think it's just the resolution, just radians, because it's just angle.
Okay. Right. Okay, radians, perfect. And then it just does it want to know which is better or something like that, or just what?
Yeah, it just wants you to compare them.
Okay.
So I suppose if you solve for each one, and then you can say like, oh, this one can see way better than that one, blah blah. I don't know.
1 million times.
Yeah, or whatever. Yeah,
Gotcha.
for sure.
Okay, that's good enough.
Yep.
Sweet.
Should have Microsoft.
It seems like physics, like in chemistry too, but like you just have to be able to visualize the problem, you know? You have to first of all, you have to understand what it's talking about.
Yeah.
Half the time I don't understand it.
Yeah.
And then
If you don't, then
otherwise, you just have to know which equation to use.
Yeah,
Just
for
plug
sure.
Stuff in.
Right, that's really all it is. Understanding like what the constant is and the equation for it.
Yeah.
Yeah.
Other than that, it's usually just algebra, you know? You get it.
Yeah.
Okay. And then I guess the last one is, well, this is
Invent and solve a resolution problem involving the pupil of your eye.
Yeah, let's work on that together. 'Cause
Okay.
otherwise I'll be consulting Google.
Yeah. Okay, so when it's talking about like, so the pupil of this is the pupil of your eye. That just means like, so you'll see in this chapter like like uppercase N, and that just is basically what do they call it? I think it's like the resolving power of your eye, basically. So it's like
I think I remember.
it's like how far you can kind of like see or whatever. So
like the closest and the farthest.
yeah. So let me see what they call it. Well, like okay, so for here, the near point. That's what it is. Yeah. So the near point is 25 centimeters for a normal eye.
Okay.
Yeah. So that's like kind of. So it wants you to use that in the equation. I think is what it's saying. So involving resolution problem. So I'd say probably resolution of the human eye would be the best section.
9.
Yeah. Yeah. So let's see. So this is magnification. So we're looking at something resolution by naked eye divided by resolution by microscope.
Is that what it's getting at though? Like it would just be like, whoa,
I
you
think
have
so.
this microscope or telescope and it has this like magnification, how far away can you see, or like what's the magnification?
I think
of
so,
the
yeah. Although, why they use resolution by naked eye, I'm not sure why they use that one. Oh, because they converted it to 80 or 25 times 5. Wait, the net result of the eye can resolve objects whose angular separation is about. Since the best light microscopes can resolve objects no smaller than about 2 nanometers at best, useful magnification is limited to about 500 times. Okay, you could. So a problem might be like, let's see here. Let's see. The diameter of the pupil varies from about 0.1 centimeter to 0.8 centimeters. So for lambda, where the eye's sensitivity is greatest, the diffraction is about that. Radius 6, the eye is about 2 centimeters long. Power of 2 at best. So maybe you could say like, I don't know, this would be a really simple equation, but you could say like, assume you're looking through a microscope at an object that's like, I don't know, like 100 nanometers or something big.
Mm-hmm.
You could say like what would be the magnification of the microscope if you like see it clearly.
So
assume like this is the resolution of the eye.
okay, the average.
Yeah. So to solve for it, you'd use like.
What is this thing? So resolution is the naked eye.
Yeah, so they get that by taking that 25 centimeters and multiplying it by this.
Okay.
Because this is like the angular separation that the eye can see.
Okay.
So that gives you 10 to the negative 4th meters, which is the resolution of the eye.
So 1/10 of a millimeter. It says.
Yeah.
Perfect.
Yep.
So you got 1/10 of a millimeter, and then divided by the resolution of the microscope. So this is the
Resolution by microscope. Yeah.
So what is this?
Oh, whoa, hold on. Resolution.
What is this referring to then? Like,
Oh, this is resolution by microscope. So that's like how. Oh, that's good.
sorry, I think it was my book.
No, it's not mine either.
Oh no.
No, it's just the schools.
Yeah.
So, let's see. Yeah, so I guess you could just kind of make a problem like, you could say the magnification of a microscope is like, I don't know, 300 times or something or whatever.
Yeah.
What is like the resolution of the microscope? Assume the revolution of the eye is like this.
All right.
And then you have to say, okay, this times 25, it gives you that. You plug it into this equation and then solve for resolution of the.
Yeah.
So something like that.
I'll just follow everything then.
Yeah, I think this is pretty much what he wants you to do.
Cool. And then instead of solving for that, I'll solve for
Yeah.
remedies.
And that makes sense to me too, because like, there isn't an example problem for this section. So like, I think he just wants you to make one up basically.
Perfect.
Because usually there's always examples, but this one there's nothing, so.
Sweet.